In our previous notes, we focused on turning a linear equation into slope-intercept form and then graphing that equation. What we want to do in this video is reverse the process and start from a graph and create the linear equation from the graph. So we start off with writing the equation of a line from a graph. All linear equations can be written in slope-intercept form. So first of all, let's add a word. Almost all linear equations can be written in slope-intercept form. Y equals mx plus b, where m represents the slope and b represents the y-intercept, or the y-coordinate of the y-intercept. Remember that the y-intercept is really 0, comma b. So when we're asked to write a y-intercept, we write it as an ordered pair. But if we're asked for b, it's just that single number. So it's a slight difference, and I'll try to point out where it makes a difference. But what about this almost? I'm hoping that from what we've learned previously, you know what that is. So we know that we can't write, so except vertical lines. Vertical lines can't be written in slope-intercept form because we have no y in the equation, because they're just x equals something, so we can never isolate the y variable because there is no y variable. All right, so let's get into these. I'm going to make this a bit bigger. All right, so number one, we want to reverse the steps. Well, it's the same steps. We want to use the same 3 steps that we did for drawing the graphs. So you may remember that step number 1 is the y-intercept. So we want to look at our graph and find the y-intercept. I'm going to use a different color, drawing on black. So my y-intercept is here at 0, comma, 1, 2, negative 4. So b is negative 4 because my y-intercept is 0, negative 4. Then step 2 was the slope. So in graphing, we used the slope to find our next point. In reading the graph, we will find another point that's exactly on an intersection. So we don't want to use a point that's in between. Like this point right here would be a really bad choice. We need to find one that is perfectly on an intersection. So we have this one, or this one, or this one. All of those are right on the intersections. And we're going to use that to find our rise and run. Notice that there are no numbers on the grid lines of this graph, so we assume that if there's no numbers, then each square is always equal to 1. So here we can go up 1, 2 units, that's our rise, and to the right 1 unit, that's our run. So our slope here is 2 over 1, which is just 2. And then our equation is just putting those 2 things together, because those are the two things we need to substitute to create a valid linear equation. So we put 2x minus 4, and now we have our equation. Number 2, we have a line going downhill, which is one of the absolute biggest things we're going to mess up reading graphs, but we're not quite there yet. So step 1. Oh, I guess step 3 here was write the equation, whereas step 3 before was connect the dots and make the graph. So step 1, our y-intercept, 1, 2, 3, 4, 5, 6. This is at 0, comma 7, meaning my y-intercept is, or my b is 7. My slope, now I need to find another point. It looks like I have one right here, a little bit to the right. So my rise, I have to be very careful. As I go to the right, it's negative 1. And then my run is 1, 2, 3. Again, there's no numbers on the grid lines, so we count them as 1 each. So my slope is negative 1/3. It's really, really easy to mix up the positive and negative. So I'm actually going to go back here and add a step 3, which is check uphill or downhill. That will keep you from making the mistake of having the wrong sign on your slope. It's the number one most messed up thing when we're writing equations from a graph. So just ask yourself, after you write this number, this is negative, is this downhill? Yeah. Or after writing this number, that's positive, is this going uphill? Yeah. So that's what you want to always ask yourself is this correct with the sign of the slope? Is it going uphill for a positive slope or downhill for a negative slope? If not, fix the sign. So here we have y equals negative 1/3 x plus 7. You can also write that as negative x over 3 plus 7, but I prefer to write it as 1/3 so I can see the rise and the run. Write a note. Okay, we already did that, so check sign of slope versus uphill or downhill. Uphill is positive, downhill is negative. Okay, number 3. We've got our y-intercept at 0, 1. So b is equal to 1. M is negative, so I'm going to go ahead and put a negative so I don't forget. And it looks like it's going down 1, right 1, so that's just a slope of negative 1. So my equation is y equals negative x plus 1. So notice I didn't put negative 1x so I didn't write negative 1x or negative 1 over 1x. Likewise in the earlier one that we did up here, on number 1, I didn't put negative 2 over 1x. We don't write 1 in a denominator, and we don't write 1 as a coefficient. So we don't write 1... no 1 in denominator or coefficient. Those are always hidden. They don't show up there. All right, number 4, we have a y-intercept that is up 2 from the origin. So b is 2. Our y-intercept is 0, 2. Our slope, it looks like the next point is right here. That's up 1, so our slope is positive, and right 2. So rise of 1, run of 2. Can't simplify that, so we get 1/2 x plus 2. Along with what I said about writing it as 1/2, not x over 2, just be careful that you don't write it as 1 over 2x to where it looks like the x is in the denominator. We want this to be 1/2 times x. So 1/2 is the coefficient in front of the x. So it can get kind of messy if we put 1 over 2x like that. Then it's hard to tell. Is that below the line or is it out to the right of the line? So try to put 1 over 2 and then x next to it like that. All right, number 5, our y-intercept is at 0, positive 3, so b is 3. Our slope, we go, let's see, this looks like our next good point here. So we go 1, 2, 3 down, so that's negative 3. And we go 1, 2 to the right, so that's negative 3 over 2. So y equals negative 3 over 2x plus 3. So 6 and 7 is more of the same. I'm going to let you try those two. So 6 and 7 are practice for you to try. They're no different than what we've done, other than 6 has a y-intercept of 0, but you've seen that before. Number 8 is the first one that's significantly different because this one is a horizontal line. And we know that horizontal lines are always y equals something. So we know the slope is 0 because it's horizontal, and our y-intercept is 1, 2, 3, 4. So we have 0, 4 as our y-intercept. And that means our equation is just y equals 4. So there won't be any slope part of it. that is equivalent to y equals 0x plus 4, but of course we don't write 0x. On this one, I just want to make sure we're clear on the 0 thing. So our y-intercept is at the origin, so that's 0. So we're going to have y equals negative 3. It's a steep line. Negative 3x, which is equivalent to y equals negative 3x plus 0, but we don't write the 0. So we never write 0 in a finished equation as a term, because it doesn't have any value. It doesn't add any information. In fact, I could add infinite zeros without changing this equation, but why would I do that? So we hide the 0 because it's not adding any information that we didn't already have without it. Same way we don't write negative 3 over 1 is we already know that that's 3 over 1, so we don't write that down. All right, that's the end of notes for today. Since there's not one, I just want to mention again, if we have a vertical line, that we cannot write it in slope-intercept form, but we can absolutely still write it from a graph. So if we have a graph, and you have a vertical line on that graph, then all you need to do is put x equals, and then find the x value that all of these points share. So in this case, it would be maybe like x equals 3. So you can definitely write the equation of a vertical line looking at a graph, but it won't ever be y equals something. And actually, I think this would be a good exercise. If we had a vertical line, for m equals, we would put undefined, because there's no numeric value because the slope doesn't exist. For b, we would put none. So there is not a y-intercept unless the vertical line were on the y-axis, in which case the y-intercept would be all real numbers because it's everything. But here there is no b, and then the equation would be x equals 3. So we can still answer these two questions, what is m and what is b, for a vertical line. It's just different because we put undefined and none rather than numeric values.